When describing the energy in sound waves, there are two variables that we use. The first is intensity. We give it a variable big I, and the intensity is defined as the power of the wave divided by the area in which we're measuring that power. Now remember, power is energy per unit time, and it's measured in watts. But power is a property of the source. So for example, if I have a speaker here, and I'm running this speaker, I'm dumping some amount of electrical energy into it that's coming out as energy in a sound wave, and that's happening in time, then there's a certain power that's coming out of this wave. And so it's a property of the source. This is a property of the source. So if I have one of these and I have 10 watts, and then I have two of them doing the same thing, then that would be 20 watts. So it's just going to be double. All right. Now the intensity though depends on the area at which this power is being dissipated. So as I think about the sound waves coming out of here, they go out in all directions, and close to the speaker I could draw a circle around the speaker, and the area of that circle would be pretty small, and so that power went out to the surface, and then the intensity at that point is fairly large because the circle area is pretty small. If I go a little further, the area of the circle's gotten much bigger, in fact by the square of the distance from it. And so the area got bigger, power stayed the same, so the intensity here is less than the intensity here. So intensity is dependent on the source. If you keep everything the same, the area the same, but you double the power, you'll double the intensity. But if you double the radius from the point you're going to reduce the intensity by 1/4 or 1/4 because the area is proportional to r squared for a spherically symmetric shape. So that's intensity. The other one is called the decibel, or the sound level, and we give it a variable beta. This is sound level, and it's measured. It's got units of decibels. It's a really weird unit, but it's actually kind of interesting of why we came up with this. Okay, this sound level has been built around the human ear and the human's brain perception of what the ear receives in terms of sound energy. Okay, so the idea is that there is a intensity called the threshold of hearing, and we give it a variable I naught that is equal to 10 to the negative 12 watts per meters squared. So remember, this is intensity, that's watts, that's meters squared. So 10 to the negative 12 watts per meter squared, which is a pretty small value. Okay, just for example, about 10 times this value would be me breathing at one end of the couch and you're sitting at the other end of the couch, and everything else is just perfectly quiet. That's how small this is. It's a very small value. Something to note about it is that it is an average. Some people can hear sounds that produce less energy than that, and some people can't even hear this, and their threshold of hearing is a bit higher. But this is kind of an average for the human population that's been measured. Okay, so with this, the idea is if this is the smallest we can hear, then why not call that 0 and rate everything else in reference to that. And the way we do it is through this, what appears at first hand to be a really convoluted way of doing it. We say that sound level of some sound is equal to 10 decibels, okay, times the base 10 logarithm of the ratio of the intensity of that sound relative to the threshold of hearing. Okay, now that just looks crazy. It's like, who came up with that one and why on earth? Well, what's cool about it is this, by doing it this way, when you get to an object that appears to be twice as loud, this gives a relative value that seems to be mathematically similar to that. And so I'll do some examples, but the important thing to recognize is that intensity is measured in watts per meter squared, and it's power over area, power being a property of the source. And sound level is relative to the human being's ability to hear anything. And so we have this I naught, the threshold of hearing, as our base, and we measure everything relative to that.